Hello everyone and welcome to the video for Algebra 1, 1 and 2 step equations. Okay, so just a little bit of a review here on how to do 1 and 2 step equations. So really no notes for this section other than just paying attention to the examples and seeing the steps that I go through with each example. Because whether it's a 1-step equation, 2-step equation, every 1-step equation pretty much has the same steps we go through. Every 2-step equation pretty much has the same steps that we go through. And if you pay attention and watch how I solve each one of these equations, you might pick up on the steps. And once again, if you know the steps to solving an equation, no matter what the equation is, no matter what numbers you're given, no matter what order those numbers and variables are in, you can solve every equation by following the same steps, okay? So first off, let's start with number 1, okay? Obviously we're going to start off with 1-step equations. So with number 1 here, we have m plus 12 is equal to 10. So that means we have some number plus 12 equal to 10. Well, you might be able to think about that in your head and go ahead and say, hey, the answer is going to be -2, okay? -2 plus 12 will give us 10. But let's see how we can do that algebraically. This is algebra after all. Okay, so algebraically, we need to look and see, well, what's the variable? Our variable is m. If our variable is m, what are we doing to it? Well, we're adding 12. Okay, so what we need to do is if we want to know what m is, and we're adding 12, we then need to subtract 12 in order to figure out what exactly m is. So that's exactly what we do. We do the opposite of what we're doing to the variable. Okay, so in this case, m plus 12, that means we need to subtract 12, but this is an equation. As you've probably learned before, if you have an equation, you have an equal sign, if you do something to one side, you have to do it to the other for it to stay equal. And what I mean by sides, just to do this, I know some of you are probably used to doing this. It's maybe drawing a line here so you can see the opposite sides. So we have m plus 12, then we're going to subtract 12. But if we do that, we need to take 10 and also subtract 12. So what ends up happening is if we add 12, then subtract 12, it's like we did nothing at all. That basically cancels out, okay? And then that leaves us with just our m, okay, which is what we want. On this side, we just got to do some basic arithmetic here. 10 minus 12. I say basic, you will get a negative number here. 10 minus 12, you have 10 things, or you have 10 and you take away 12. That'll leave us with -2. Okay, and then that is actually our answer. So 1-step equation, that easy. 1 step, we're done. There's our answer. And just so you know, we can take this answer, plug it back into our equation, so -2 plus 12, and we can make sure that gives us 10. So that tells us we did this correctly. We checked our equation. It is correct, okay? Number 2, kind of similar, except for one thing you notice is the g, the variable in this case, is on the right-hand side of the equation instead of the left-hand side of the equation. So what we can do to help with this, if we want to, we technically can solve it just as we are here, because we just need to look, what's the variable? G. What are we doing to g? Subtracting 9. So that means we need to do the opposite, which is add 9. Okay? But if we add 9 over here, we got to add 9 over here, and we can solve the equation with the variable being on the right-hand side. But as you'll see as I go through with all of these, I kind of like to have my equations fit the same form here. So I like to have the term with the variable plus or minus. So first off, I like to have my variable on the left-hand side of the equation. And then I like to have the terms without the variable on the right-hand side. So that way when I solve it, I get something like this. M is equal to -2. Okay? So if we want to do that here, we can think back to one of the properties we've talked about, which is the symmetric property. And we can take this, and since this is an equal sign, we can actually flip the equation around. So we get g minus 9 is equal to -2. Okay, once again, all I did was flip across the equal sign here, which that's because of the symmetric property. Okay, now we can go about solving it just like we did over here. we have g. We're subtracting 9, so that means we need to add 9. If we do it to one side, we got to do it to the other. G minus 9 plus 9. Essentially, the 9s will cancel out, leaving us with g. And that's going to be equal to negative 2 plus 9, which gives us positive 7. Once again, if you're used to doing this little line down through here so you can separate the sides, that's perfectly fine. But we do end up with g is equal to 7. Okay? So to pick it up a little bit here, or not pick it up, but we will go a little bit quicker as we go along because, once again, it's pretty much the same steps every time. We find the variable, we see what we're doing to the variable, and then we just work backwards and do the opposite. So in this case, negative 7 times y is equal to negative 91. Okay? Well, negative 7 times y, well, first off, the variable's y. What are we doing to y? Well, we're multiplying it times negative 7. So what's the opposite of multiplying times negative 7? Well, that's going to be dividing by negative 7. So if we take this, we have to divide this side by negative 7. But this is an equation, so if we divide one side by negative 7, we need to divide the other side by negative 7. So the negative 7s essentially cancel out, giving us 1y, which is what we want. We want 1y is equal to negative over a negative is a positive. And this one's a little bit tricky, but you can do it in your head if you're clever about it. But if you need to, double check yourself in a calculator. 91 divided by 7 is 13. Okay, so that is the answer. And I'm going to kind of stop drawing the line here because that could maybe confuse some people in terms of saying, oh, that's not equal to 13. But if you need to draw the line so you can delineate which side is which for an equation, there's no problem with that. Just make sure the end result is correct here in terms of y is equal to 13. Number 4, very similar to number 3, except for instead of multiplication in this problem, we have division. So we have the letter A divided by 9 is equal to negative 4. Once again, A is our variable. We're dividing it by 9. Well, what's the opposite of dividing by 9? That is multiplying times 9. But just like before, if we do something to one side, we got to do it to the other. Multiplying 9 times a over 9, the 9s simply cancel, giving us 1. 1 times a, so we have 1a is equal to, which is what we want. The whole goal, every single equation that we solve, we want to get what we don't know on one side by itself. Okay? And like I've said before, usually we like it on the left-hand side because it makes it go easier in terms of reading the answer. So like y is equal to 13. Okay, but in this case, we've got a is equal to negative times a positive is going to be a negative. 4 times 9. If you know your times tables, that is 36. So negative 36. All right, and that's pretty much how you do every single one-step equation. Now we will go on to the next one, the next set of questions here. But as you see, and this will probably bring some anxiety into some people, we're going to deal with fractions. Okay, well, how do we deal with fractions when we have a one-step equation? Well, fractions are just numbers. They're just numbers that we have to write as fractions, meaning we have to write them with a numerator and denominator, because if we wrote them out, and especially like something like 2/3, if we wrote that out as a decimal, that's a pretty nasty decimal to have to deal with and do arithmetic with, okay? So to help us with this, we have a little shortcut, a little rule that we can follow. So here we see the variable is x, okay? We have the fraction 2/3 times x is equal to 10. Well, since we're multiplying x times 2 over 3, technically what we would need to do is divide both sides by 2 over 3. But you can see, so let me write this down real quick. You can see this could be a little bit of a problem, because if we divide by 2 over 3 over here, we got to divide by 2 over 3 over here. Dividing by a fraction, you got a fraction over a fraction, okay, or a number over a fraction. That looks pretty freaky. That looks pretty weird, okay? So instead of dividing by a fraction, what we can actually do is do this little trick where we multiply both sides by what we call the reciprocal, meaning we take whatever the fraction is and flip it over. So the reciprocal of 2 over 3 is 3 over 2. So if we multiply those together, that will actually cancel out and give us what we want over here. We'll get the number 1, but 1x, which is x. But once again, if we multiply this side times 3 over 2, we've got to multiply this side times 3 over 2. And some people still freak out because you got to multiply a whole number times a fraction. Well, how do we do that? Well, if we wanted to not use a calculator, all you got to do is change your whole number into a fraction. And then how do we multiply fractions? Well, we multiply straight across. So 10 times 3 is 30 over 1 times 2, which is 2. Once again, should be something you should be able maybe to do in your head. 30 divided by 2, we get that is 15. And that's actually our answer, the nice number of 15. And look, we had that nasty fraction. If you put that fraction into a calculator, you actually get 0.6 repeating, or 0.666666666 ... Goes on forever, okay? So that's a nasty decimal that we would have to deal with. But since we dealt with it as a fraction, the number just came out to a nice even 15, okay? X is equal to 15. Same thing with number 6 over here. 4/9 times W is equal to -8. Once again, we have this fraction times our variable, so that means we need to divide by this fraction. But if we remember our little trick, instead of dividing by a fraction, we can just multiply by its reciprocal. So if we have 4 divided by 9, or 4 over 9, its reciprocal is going to be 9 over 4, so 9/4, okay? But we got to bring it over here and do the same. Okay, so in this case, 9/4 times 4/9. Same thing we had happen earlier, and you'll see this is a common thing with the next few examples here. Those cancel out, leaving us with W. Here we've got negative times a positive, so we know our answer is going to be negative. And then we have the same kind of thing here. We need to put our 8 over 1, so 8 times 9 is going to be 72 over 1 times 4, which is 4. And don't forget, once again, we have this negative out here, but I've already taken care of it here. So we know negative times a positive is a negative. 8 times 9, 72. 1 times 4, 4. And then all we need to do is simplify this fraction. So negative 72 divided by 4, okay? Once again, should be able to possibly do that in your head, but if not, once again, that one's a little tougher. So if you do need to double check yourself by using a calculator there, you'll see that the answer is -18. Okay, so 72 divided by 4 is 18, so we have a -18. The next two examples, very similar, except for we introduce negative fractions. So once again, that's double anxiety for some people with, the negatives and the fractions. But it works very similarly, okay? The only difference is when we write our reciprocals out, we have to make the reciprocals -2. So if we have -6/5 here, the reciprocal of that's going to be -5/6. So times, and I'm going to put parentheses here, -5/6. So if your fraction is negative, well, its reciprocal also has to be negative. So we have a negative times a negative, which will be a positive. Those will cancel out, giving us 1. So we get a positive 1k, which is what we want. Same kind of thing here. We have an issue where we have a whole number times a fraction. We put that over 1. We have a positive times a negative, gives us a negative. 12 times 5 is 60. 1 times 6 is 6. And this is one definitely people should be able to do in their head. Negative 60 divided by 6, that's going to leave us with a 10. So the answer is -10. And lastly, same thing, pretty much same thing as what we just did, except for the number on this side is also negative. But exact same process. We have a negative fraction here, so a -1/2. Well, that means we need to multiply it times a -2 over 1. times negative 2 over 1. Okay, once again, the whole point here is negative times a negative gives us a positive. Those cancel out, leaving us positive 1m. Here we have a negative times a negative, so our answer is going to be positive. Technically, we don't have to do this because we can see, okay, negative 2 over 1, that's just negative 2. But let's just play along, just practice with doing fractions here. Negative times a negative, positive. 9 times 2 is 18 over 1 times 1, which is 1. And we can simplify that as just, if it's 18 over 1, that's just the number 18. Okay? So that's pretty much one-step equations. You just have one step to do. Maybe some instances like this where we have to do a little simplification, but I don't really call that a step. That's more just, like I said, arithmetic. Okay? The steps that we're talking about here is the operations we have to do. Okay? So in this case, we had to do one operation. We had to multiply both sides by the reciprocal. Same thing with both of these, multiplying by the reciprocal. Here we had to multiply times what we were dividing by, okay? Because once again, we want to do the opposite. Here we had to divide by what we were multiplying by. Once again, opposite of multiplication is division. Opposite of division is multiplication. Opposite of subtraction is addition. Opposite of addition is subtraction. So as long as you do the opposite, okay, to whatever you're doing to the variable, that's really the trick to solving one-step equations. But now let's jump ahead and do two-step equations, and I'll give you a little hint. Okay, in order to solve two-step equations, we are going to also have to know how to solve one-step equations. So what we just did is actually building into this two-step equations, because you'll see when we work this first one out, we're going to get to a point where we have to solve a one-step equation in order to figure out what the variable is, okay? So number 9, 6x plus 8. So 6 times x plus 8 is equal to 50, okay? So once again, we notice the variable here is x. We don't know what x is. Well, what are we doing to x? Well, if we were to plug a number in, think of the order of operations. We would take x and we would multiply times 6, then we would add 8, okay? So if we were going backwards and we wanted to solve and figure out what x is, we have to work backwards. So we undo the last thing first, meaning if we multiply times 6, then add 8, that means we need to subtract 8, then divide by 6. Okay, so those are the two steps we got to do. And it's given to you by what you're doing to x right here. We got to do the opposite of the addition, which is subtraction. We got to do the opposite of multiplication, which is division. But the order that we do that matters. We can't divide both sides by 6 first, then subtract 8, because order of operations doesn't allow us to do that. So if you need to, and I'm going to write it up here for reference, and if you need to, write it on your paper, we are following order of operations, except for we are going backwards, okay? So we have to take care of the addition before we take care. So addition, and you'll see me write PEMDAS like this. But order of operations, addition has to be taken care of before multiplication. You could see the last thing, and you'll see this in later sections or when we solve tougher and tougher equations, the last thing that we want to do is what's inside parentheses. Well, we don't have any parentheses here, okay? So we don't have to worry about that. All we have to worry about in this case is what do we do first between taking care of addition or getting rid of addition or getting rid of multiplication? Well, we needed to get rid of the addition first. So that means the first step is subtracting 8. But same as what we did before. The equation, we subtract 8 over here. We need to subtract 8 on this side too. So the whole point here is those cancel out. So we're left with 6x is equal to 50 minus 8, 42. Okay, and now this is the part I was talking about earlier. This is nothing more than a one-step equation. 6x is equal to 42. Well, what are we doing to x? We're multiplying times 6, so we need to divide by 6. But if we do it to one side, we got to do it to the other. Those cancel out, giving us 1x is equal to 42 divided by 6. Once again, if you know your times tables, you should know that is 7. Like I said, it doesn't hurt to double check yourself. So if you need to do 42 divided by 6 in your calculator, I would much rather you double check yourself and make sure you were right than to put something here like 8, just because you mistakenly thought 42 divided by 6 was 8. Okay? So the answer there is 7. But you can see where the two-step equation gets its name. What were the two steps we had to do? Well, we had to do subtraction, then division. Because once again, those are the opposites of addition and multiplication. And like I said, it always follows the order of operations. So let's look at number 10. 2 times n minus 5 is equal to 11. Well, if we have n here, we're plugging in a number. So let's say we plug in, it doesn't matter what number we plug in. If we plug in a number here, we're going to multiply it times 2, then subtract 5. Meaning the order in which we need to do things is we need to add 5, then divide by 2. Okay? So again, following this order here. So dealing with subtraction comes before dealing with multiplication. So that means, first step, add 5 to both sides. So here, these cancel, giving us our 2n. 11 plus 5 is 16. 2n is equal to 16. We have another one-step equation where the only step that's left is to divide by 2. So once again, the whole point here is we get 1n. 16 divided by 2. Once again, if you know your times tables, you should know that is actually 8. So 7 and 8 are the answers to 9 and 10. Okay, and I haven't said this in a few examples here, but if you wanted to know if you did this right, take what you got here and plug it back in. 2 times 8 is 16. 16 minus 5, that gives us 11. And once again, this all stems around order of operations. If you don't know order of operations, you are going to be in some trouble, because especially as we get into harder and harder equations, you're going to rely on order of operations to let you know what order you need to do the steps, okay, in our equations. So let's go ahead and go to number 11. Number 11, we have the same kind of thing happen that we had earlier, where the variable's on the right-hand side. So if we need to, and it's not necessary, but if it helps you, flip across the equal sign. Use the symmetric property. So we can rewrite this as negative 4k plus 9 is equal to 13. And now it works exactly the same as what we did in the last two problems, where we have k. Well, what would we do to k? Well, we would multiply times negative 4, then add 9. So that means we need to subtract 9 and then divide by negative 4. So those are the two steps. So subtract 9, getting rid of those, leaving us with the negative 4k. And that's equal to 13 minus 9. Again, probably should be something you could do in your head there. 13 minus 9 is 4, okay? And then, once again, what do we get? Well, it should be no surprise at this point. We get a one-step equation where we have to divide both sides by negative 4. So once again, the whole point here, those cancel out, leaving us with k. 4 divided by negative 4, we have a positive over a negative, which should be a negative. 4 divided by 4, pretty easy, that is 1. So the answer here is negative 1. Okay, and number 12. And as you see, I got a little star by this one because this one's got a little special thing, a little special trick that you can use to help you organize your equation to make it look like all the equations we've done beforehand. Because this one's got a little special thing happen here where we've got actually 7 minus 3y, okay, is equal to 34. So we've got the constant term or the number term in front of the variable term. So there's a lot of people that would be tempted to write this. They would go in and they would say, okay, 7 minus 3y. Well, I want the 3y out front, so I'm just going to write this. 3y minus 7 is equal to 34. That is completely wrong, okay? If you know anything about subtraction, the order in which you subtract things matters a lot, okay? So since this is subtraction, we can't just flip the numbers around, okay? That's because that goes against the commutative property. If if you remember talking about properties. Commutative property does not work with subtraction, okay? So commutative property only works with addition. Well, here's the trick. If you can take your subtraction and write it as addition, meaning take your subtraction, make it into a plus, well, then that negative has to go somewhere, okay? So the way you can think about it is this negative has to go with the term that comes after it. So in this case, if you change your subtraction to addition, the negative has to go with the 3y, okay? Just like a little trick we can use. And now, since we do have addition here, we can simply flip across the plus sign, okay? Because once again, we've got the commutative property. We can say negative 3y plus 7 is equal to 34. Once again, that's a common mistake a lot of people make. So that's why I put a star by this one. If you need to, circle it. Do something on your paper because this one stands out because we're going to actually use this trick a lot later on when we're talking about more advanced equations, okay? But now you can see, since I've written it this way, works exactly the same as what we just did in number 11. We're going to subtract 7 because once again, we got y. We're going to multiply times negative 3, then add 7. So in this case, we need to subtract 7, then divide by negative 3. So if we subtract 7, boom, negative 3y is equal to 34 minus 7. A little tougher, but I feel like a lot of you could do that in your head. It's going to be 27. And then lastly, divide by negative 3, divide by negative 3. The negative 3's cancel, giving us y is equal to 27 divided by negative 3. Positive divided by negative, which is a negative. Once again, you know your times tables, 27 divided by 3, it gives you 9. So it's going to be, the answer is negative 9. Okay, so we're over halfway there. So let's go on to the next ones. And as you see, we still have two-step equations, except for instead of multiplication and then addition or subtraction, we have division and then addition and subtraction. So in this case, division and subtraction. If you need to, write at the top of your paper PEMDAS again, but if you think of PEMDAS and working backwards, if you plug something in for x, what would you do? Well, you would divide it by 2 first, then subtract 7. So that means we need to add 7, then multiply times 2. Okay, once again, always working backwards, always doing the opposite. We don't really care what's over here because what tells us what we need to do is on this side, okay, the side with the variable. The variable tells us what order we need to do things because of the order of operations. Divide by 2, then subtract 7. So that means to go backwards means to add 7, multiply times 2. So we need to add 7. If we do that, the 7's cancel out, so minus 7 plus 7, leaving us x over 2. 9 plus 7, once again, should be able to do that in your head. That's 16. And then lastly, once again, another one-step equation. X divided by 2 means we've got to multiply times 2, do the opposite. So if we multiply that side times 2, we got to do this side. Point is those cancel, leaving us with x. 16 times 2 is 32. Okay. And like I said before, any of these equations, if you want to check and see if you got this right, take your answer and plug it back into the original expression. 32 divided by 2 is 16. 16 minus 7 is 9. Okay. Number 14, very similar to what we just did, except for, as you see, we've had this problem before, the variable's on the right-hand side, which technically isn't a problem at all. If you can see how to solve this equation from here, it's going to be the same steps. It's just you're going to end up with your variable on the right-hand side instead of the left-hand side. But I like to stay consistent, so I'm going to rewrite this as c over negative 5 plus 8 is equal to 11. Same exact thing. All I did was use the symmetric property and flipped across the equal sign. Now, same thing we did over here. If we had c, we would divide it by negative 5, then add 8. That means we need to subtract 8, then multiply times negative 5. So those are the steps. So subtract 8, c divided by negative 5 is equal to 3. Multiply times the opposite, or do the opposite here. So opposite of division is multiplication. Multiply times negative 5. The whole point here is those cancel, leaving us with c. Positive times a negative is a negative. 3 times 5. Once again, times table comes back for us. It's 15. Alrighty, moving right along. Now we run into probably the toughest types of questions you'll face in this section, okay? Barring maybe the last few. I know the last few questions probably will trip a few people up. But this one, two-step equations involving fractions, okay? But the trick here is you have the fraction here multiplied times the variable. Well, it follows the order of operations the same. If you plugged in for x, you would multiply times 3/5, then add 22. That means you need to subtract 22, then technically divide by 3/5, but we already talked about this earlier. Instead of dividing by fractions, what do? Well, we multiply by the reciprocal, which I realize I didn't write that out. That's actually the blank that you fill in there underneath the fraction part. Multiply by the reciprocal, okay? So we're going to use that same idea when we come to number 15. 3/5 x, so 3/5 times x plus 22. That means we're going to subtract 22 first. Once again, we do it to one side, we got to do it to the other. Those will cancel out, leaving us with 3/5 x is equal to 28 minus 22 is 6. Okay. Well, once again, what do we have? If we look at this looks exactly like number 5, except instead of 3/5, we have 2/3. And instead of 6, we had 10. But it works the exact same way. We're going to multiply both signs by the reciprocal of 3/5, which is 5/3. 5/3. So again, the whole point here is those will cancel, giving us 1x is equal to, and then like I said before, this is a place where people get mixed up. But if we remember, we can turn whole numbers into fractions. Then we just multiply them just like any two old fractions. 6 times 5 is 30. 1 times 3 is 3. And then the last step here, which technically isn't a step in terms of doing an operation, all we got to do is simplify this. So 30 divided by 3, we can simplify that as 10. So if you look at that, very similar to what we did in number 5, okay? Except for there we had 30 divided by 2 because that's just the way the fractions worked out, okay? So we had 30 divided by 2, which is 15. Here we get 30 divided by 3, which is 10. Number 16, exactly the same, okay? Except the only difference is instead of a positive fraction here, we have a negative fraction, okay? So with that being said, the steps are still the same. If we had m, we'd multiply it times negative 1/3, then add 1. So we need to subtract 1, divide by negative 1/3, but that we know that at this point that really means multiply times its reciprocal, so negative 3/1. So let's first do the first step. This is the easiest step. Subtract 1. Once again, those will go away, giving us negative 1/3 times m. Negative 7 minus 1 is negative 8. So here's where we get to the same point we were over here, except for we got to remember we need to multiply by the reciprocal. And the reciprocal has to be the same sign as the fraction that we have here. So since this is a negative 1/3, the reciprocal is negative 3/1. So we have to do the same thing over here, negative 3/1. So the whole point here is those will cancel out. Negative times a negative is a positive 1. So this is m is equal to negative times a negative is a positive. We can take a little shortcut here and say, okay, negative 3/1, well, that's just going to be 3, negative 3. So technically you could say negative 8 times negative 3. That's just going to be positive 8 times 3, which is 24. But just to be consistent, negative times a negative is a positive. 8 times 3 is 24 over 1 times 1, which is 1. So if we simplify that, that's simply 24. Okay, so we're almost there. So last couple of these types of questions, we have the same issues we did before, except for now we've got fractions instead of whole numbers here, okay? But the same kind of thing happens if we need to. This is addition, so we can flip this around and say this is 7/4 p plus negative 10. Okay, there's a couple ways you can go about this. You can see that you're adding a negative. So if you're clever with it, you can say, well, adding a negative is the same as subtracting the positive. So you can rewrite this as 7/4 p minus 10 and solve it that way. But I'm just going to leave it as it is. We have plus negative 10, so that means we need to subtract negative 10. But if we subtract negative 10 over there, we need to do it over here. Those cancel, leaving us with our 7/4 p. Negative 38 minus negative 10. Maybe a little tough there, but once again, don't let the negatives throw you off, okay? Negative 38 minus negative 10. So you might have had a teacher tell you before that if you subtract a negative, that's the same thing as adding the positive. So in a way, you can think about this as negative 38 plus 10, which is negative 28. Okay? And then from there, same exact thing. So we have the fraction 7/4 times p. So that means we need to divide by 7/4, or once again, take the shortcut here, multiply times 4/7. So if we do it to one side, we got to do it to the other. This is where we run into a little bit of an issue because we got some bigger numbers over here we're trying to multiply, but this side's easy. Those cancel, giving us p. Negative times a positive. We know the answer is going to be a negative. Let's be consistent with it here. 28 times 4. Once again, that one's tough to think about maybe in your head, so if you need to double check yourself on a calculator, I would much rather you do that than just guess and end up getting this wrong. But 28 times 4 is going to be 112 over 1 times 7, which is 7. And we still got something pretty nasty looking here. 112 over 7. Okay, well, once again, negative 12 divided by 7. If you need to, double check yourself on a calculator, but I'll go ahead and tell you. This is going to give us, negative 112 over 7 is going to give us 16. But once again, we can't forget our negative. It's negative 16. Okay? But like I said, same steps. It's just, once again, sometimes we got negative numbers. Sometimes we got fractions. Sometimes our order is reversed here. Okay? So, like I said, all these little tricks are going to be relevant because you'll see this all the time where you might need to move things around. Once again, technically you don't need to move things around. If you see you need to solve this by adding 10 to both sides, first, that's perfectly fine. I'm just showing you to stay consistent that if you like it in the same order, you can see that it's the same steps every single time. It's just doing these tricks. So using a commutative property, using a symmetric property, using a commutative property here, we're going to have to do that because we have 15 is equal to 9 minus 1/2 x. Well, we're going to have to use actually both commutative and symmetric properties here to write it in the way that we like. So first off, let's use a symmetric property because that's the easiest. So all we got to do is write one side as the other. And that's the symmetric property. Now we have this issue where we have 9 minus 1/2 x. Technically, you don't have to move things around, so you can subtract 9 from both sides. But just to be consistent, let's move these around. But we can't do that until we take care of this subtraction. So I'm going to rewrite this as 9 plus negative 1/2 x. And just like for the same reasoning as before, if we change our subtraction to addition, that means the negative has to go with the 1/2. So it has to go with what comes after it. So in this case, we have plus negative 1/2 x. Now we can flip it with this commutative property. Negative 1/2 x plus 9 is equal to 15. Exact same thing as what we just did in number 17. We're going to subtract 9 first. So we have negative 1/2 x, because these will cancel, is equal to 15 minus 9, which is 6. And now we need to multiply both sides by the reciprocal of negative 1/2, which is negative 2 over 1. And same story here, broken record. Negative times a negative is a positive. We're going to get a positive 1. So we get x, positive 1x is equal to positive times a negative is a negative. 6 times 2, once again, be consistent. 6 times 2 is 12 over 1 times 1, which is 1. This is nothing more than negative 12. Now it's probably the most complicated question on this whole sheet, okay, because we had to use, in order to write it in the way that we wanted to, we had to use both the symmetric property and the commutative property, okay? And then on top of that, we had to use this idea of changing our subtraction to addition, okay? Like I said, that's a little trick that's going to come in handy down the road. So if you figure this out and understand what I'm talking about here, that will help you so much later on when we're solving some of these tougher equations. But now let's go on to number 19. And on the sheet there, okay, when you see it, it says warning, or it says something like warning, okay? Well, that's because with these, you run into a little issue where you don't actually deal with the addition or subtraction first. Here you have to deal with the multiplication or division first. In this case, you got to deal with the division first, okay? So if you look at number 19, we have x plus 1, all of that over 8. So once again, we see this fraction bar here. Well, what's being divided by 8? Well, both the x and the 1, so x plus 1, okay? So we can't simply subtract 1 from both sides just because we're adding 1 to x. We have to think about order of operations. Once again, PEMDAS, not a B, a P. Okay, once again, I like to put the parentheses around there. If you had me in class, you know why. Okay, but in this case, what are we doing to x? Well, if we put something in for x, we would actually add 1 first, then divide by 8 by order of operations. Because if we remember correctly, P, or sometimes you'll see it referred to as GEMDAS, okay, which means grouping symbols. The fraction bar acts as a grouping symbol. So it groups the numerator together and the denominator together. So since it groups the numerator together, that means we have to do what's in the numerator first before we divide by 8. So we have to do x plus 1 first, then divide by 8. So we're adding 1, then dividing by 8. So that means we need to multiply times 8, then subtract 1. So that's the order we have to do things here. Okay, so the whole point here is if we divide by 8 and multiply times 8, that's just going to cancel out, giving us what's on the top, which is x plus 1. Negative 3 times 8, that's a negative times a positive, which is a negative. 3 times 8, 24. And then lastly, we have a one-step equation where we take x plus 1. So we need to subtract 1. Once again, the whole point here is those cancel, leaving us with x is equal to negative 24 minus 1. We get the answer of negative 25. Okay? So negative 25. Oh, I do see there's a little error. So this is first here. This should actually be plus 11. So that should be plus 11 minus 11. So it actually gives us negative 35. So I do apologize for that little, not really typo, a righto there. But once again, that's simply because I left off something there. And it's a good point to make here is that always make sure you copy down your problems correctly. Okay, so even I make those mistakes. So if I make them, It's easy for you to make them, so just make sure you copy down your problems correctly. So the answer is actually negative 35. Okay, so negative 24 minus 11, negative 35. We do the same thing here. If we plugged in something for n, we would do n minus 5. Then we would divide by negative 2. But since the n minus 5 is kind of grouped together here because of this fraction bar, we need to do, okay, so since we're subtracting 5, then dividing by negative 2, that means we need to multiply times negative 2, then add 5. So first step here is multiply times negative 2. Multiply times negative 2. Whole point here, those cancel. We have n minus 5 is equal to negative times a negative, which is a positive. 7 times 2, 14. An easy one-step equation here. Plus 5, n is equal to 19. Okay, so you can see on these types of questions, after you get through the first part and understanding you have to multiply first before you add or subtract, it actually becomes super easy because after you do that first multiplication, you get some of the easiest one-step equations you can have, okay? Number 21, same kind of thing except for it's flipped around, so let's go ahead and use a symmetric property. So a minus 13 over negative 6 is equal to 1. So once again, a minus 13 is kind of grouped together there, so we got to multiply times negative 6 first. Okay, because that's what we're dividing by. So the whole point there is those cancel. We get a minus 13 is equal to 1 times anything is that thing. So in this case, 1 times negative 6 is negative 6. And then we add 13. So in this case, we get a is equal to 7. And lastly, okay, with this one, same kind of thing as number 21. It's on the opposite sides, but this one actually to me is easier because everything's positive. There's no subtraction. So if we rewrite this using the symmetric property, all we got to do is see, okay, w plus 8, it's in the numerator. So that means it's grouped together. So we would add 8, then divide by 9. So that means we need to multiply times 9. Then after that, we're going to subtract 8. So we're going to get rid of that. So w plus 8 is equal to 4 times 9. We've seen that before. That's 36. And then we need to subtract 8 since it's the opposite of adding 8. So we get w is equal to 36 minus 8, 28. And that's all of the example questions and basically notes, if you want to call them that, for this section. Okay, do make sure to practice using the 1 and 2 step equations with the little activity that's added onto your packet. And if you go do that, I do suggest going and doing that before looking at the next part of the video, because I'm going to give you the answer to the maze or to the activity, so that way you can check yourself. So if you'd like to, pause the video right now, go try the activity. Okay, there's a 2-step equation maze there. Go do that activity and then come back and I'll show you the solution. Okay, so give you a couple seconds and here we go. Here's the solution. So here's the 2-step equation maze. So in order to solve this, I'm not going to go through and work every single one. This video is already too long as it is. But in this case, I'm going to highlight for you the path that you need to go. So you're going to start here by solving this equation. Well, the equation, when you solve it, it's going to give you an answer. And based on the answer, that tells you which box you go to next. So as I write this, this tells you from each equation which box you go to after that to solve that equation. Now, if you don't go to one of the boxes, you don't have to go and solve those equations, okay? Now, if you wanted to for the extra practice, you could. If you'd like to do that, let me know and I'll give you the answers to all these. But the official answer to this is you're going to start in this box, okay? And then we're going to go down diagonally to this box, okay, which takes us up to this box, then to the left or to the right to this box, to the right again to this box, down to this box, diagonally to the left to this box, to the left to this box, to the left to this box, diagonally to the right to this box, and lastly from here to there, and then we get to the end. Okay, so essentially how you check yourself to make sure you did this correctly is the answer to 4x plus 10 is equal to negative 26. You should get negative 9. Okay, so the negative 9 tells us we go down to this box. Okay, and that's going to be a little bit of a weird thing there in terms of the darker. So let me erase that and kind of redo that so it looks a little better here, but I guess the damage is already done. So this will look a little better, I guess. But all this means is we go from this box to this box because we got a negative 9. So that should mean the answer to 1/2 x plus 13 equals 9 should be negative 8. The answer to x over 3 or x divided by 3 plus 10 equals 15 is 15. Okay, so once again, follow the boxes. Based on that, the answers are given in between each box. So double check yourself and make sure this is the path that you got. If not, go back and practice some more before you do your homework, because if you can do these, you can definitely do all the equations that are on the homework. Okay. But other than that, if you have any questions, please let me know. And I thank you for watching.